scientists say there's a place in our solar system outside of Earth that has the chemical makeup to potentially support life. That place is Enceladus.
For centuries, scientists have been exploring our neighbors in the solar system to see if there is a possibility of life on them. So far, there have been many groundbreaking discoveries from these space missions. The most recent is NASA's revelation of the possibility that Enceladus, Saturn's moon, is habitable for extraterrestrial life. We owe this discovery to the magnificent James Webb Space Telescope, which captured images of a water plume erupting from the underground layer of Enceladus. However, this eruption is like none of the space discoveries we have seen before, as it surpasses the boundaries of Enceladus itself. NASA made this groundbreaking discovery in 2022, but didn't reveal it to the public immediately. What's so special about this water plume that was seen in Enceladus? Why did NASA wait till now before informing the world of this mind-blowing discovery? Join us in this video as we explore why NASA finally broke its silence on the ocean world that the James Webb Telescope detected in Saturn's moon Enceladus. Saturn is one of the planets that keep on fascinating scientists. Even though they have been studying Saturn since the 17th century, they have barely scratched the surface of this interesting planet. It is the second largest planet after Jupiter and the sixth planet from the Sun. Like its twin Jupiter, it is called a gas giant because it is composed of hydrogen and helium. Saturn is 1/8 the average density of the Earth, but it is over 95 times larger than the Earth. It has a pale yellow hue due to the presence of ammonia crystals in its upper atmosphere. It also has a prominent ring system that comprises mainly ice particles, with a small amount of rocky debris and dust. Unlike the Earth, which has just one moon, Saturn has at least 146 moons. That's a whole lot of satellites, right? So far, only 63 of these moons have been officially named by scientists. Saturn's largest moon is Titan, the second largest moon in the solar system. Since the discovery of Titan in 1655 by Dutch astronomer Christian Huygens, it has been the subject of several scientific research and explorations, which have made us know it is primarily composed of ice and rocky material. Another Saturn moon that continues to keep scientists engaged is Enceladus. With a length of 513.2 kilometers, Enceladus is the sixth largest moon of Saturn and the 19th largest in the solar system. It is a small moon made up of ice and rock. However, what Enceladus lacks in size, it makes up for with its varied landscapes, ranging from old, heavily cratered regions to young, technically deformed terrain. It is one of the major inner satellites of Saturn, along with Dione, Tethys, and Mimas. The rate at which Enceladus orbits around Saturn is fast enough for its motion to be observed over a single night. In addition, extensive linear cracks and scarps have been observed on the Enceladus's surface. Enceladus was discovered on the 28th of August, 1789, by Frederick William Herschel. Enceladus was named after the giant Enceladus of Greek mythology. It was William's son, John Herschel, who suggested the name. Herschel, a German-born British astronomer, discovered Saturn's satellite during the first use of his 40-foot telescope. At the time, Herschel's telescope was the largest in the world and was situated at the observatory house in Slough, England. Smaller telescopes had not previously discovered Enceladus because of its faint apparent magnitude and proximity to the much brighter Saturn and Saturn's rings. However, Herschel discovered a Saturnian equinox when the Earth was within the ring plane. During such periods, there is a reduction in the glare from Saturn's rings, which makes it easier to observe its moons. The interest of astronomers had been piqued since Herschel first spotted Enceladus, and they wanted to know more about Saturn's moon. For centuries, scientists kept observing Enceladus with different telescopes, but they could only determine its orbital characteristics with predictions of its mass, density, and albedo. None of their telescopes were sophisticated enough to give a better view that would help the scientists evaluate what was happening in Enceladus. However, the Voyager missions enriched our understanding of what Enceladus looked like. What were the Voyager missions? In 1977, NASA launched two robotic interstellar probes called Voyager 1 and Voyager 2 into space. The purpose of the space mission was for the spacecraft to take advantage of the favorable alignment of the two gas giants, Jupiter and Saturn, by flying near them to collect data that would be transmitted back to the Earth. Voyager 1 and Voyager 2 provided scientists with close-up images of the Enceladus, elevating the level of research that had been done so far. Voyager 1 was the first to fly past Enceladus on the 12th of November 1980. It had been moving at 202,000 kilometers, so the images acquired had poor spatial resolution, but showed that the Moon had a highly reflective surface free from impact craters. Scientists interpreted this information to mean that the Enceladus had a youthful surface. Future observations of Enceladus would prove that this hypothesis was correct. The observation of Voyager 1 confirmed astronomers' suspicion that the Enceladus was embedded in the densest part of Saturn's diffuse E ring. Nearly a year later, Voyager 2 passed closer to Enceladus on the 26th of August, 1981. The space probe had been moving at a distance of 87,010 kilometers, so it could obtain high-resolution images. From these images, it was confirmed that Enceladus had a young surface. Further studies showed a surface with different regions that had varying surface ages. The Voyager mission revealed that there are two regions of smooth plains on the Enceladus, and they were named Serendib Planitia and Diyar Planitia. Better high-resolution images of these plains have shown that they are composed of low-relief ridges and fractures, which were likely caused by shear deformation. The southern polar region of Enceladus is covered in tectonic ridges and fractures. The region has a few sizable impact craters, which means it is the youngest surface on the satellite. Enceladus had a geologic diversity of heavily cratered mid to high northern latitude regions and a lightly cratered region close to the equator. The geologically youthful terrains of the Enceladus puzzled astronomers because no theory could predict that such a small satellite body could bear such activity. Not satisfied with their answers from the Voyager mission, NASA scientists began work on another space program. This was understandable because there was still a lot we didn't know about the Enceladus, and it only felt right to probe further. It would take astronomers another 2 decades to explore Enceladus and Saturn better. On the 1st of July, 2004, the Cassini spacecraft entered orbit around Saturn after leaving the Earth in 1997. NASA developed the Cassini space mission in partnership with the European Space Agency, ESA, and the Italian Space Agency, ASI. The collaboration paid off because the space mission demystified several huygens about Enceladus. Officially known as Cassini-Huygens, the robotic spacecraft comprises NASA's Cassini space probe and the ESA's Huygens lander, which had landed on Titan. Enceladus was a priority target for the Cassini space mission, so the spacecraft embarked on several targeted flybys within 1,500 kilometers of the Moon's surface and carried out many other non-targeted opportunities within 100,000 kilometers of Enceladus. Thanks to the flybys, astronomers uncovered water vapor on the Moon and traces of simple hydrocarbons escaping from the geologically active South Solar region. Scientists were so fascinated by these discoveries that they had to adjust Cassini's flight plan to allow closer flybys of Enceladus. This adjustment led to an encounter in March 2008 that took the spacecraft within 48 kilometers of the surface and 7 close flybys of Enceladus between July 2008 and July 2010. The flybys revealed far more information than what astronomers had seen since the discovery of Enceladus in the 18th century. The most exciting information we have gotten from Cassini's mission to Enceladus is that there is strong evidence that it has an ocean with an energy source, nutrients, and organic molecules. This means Enceladus is one of the best places to study potentially habitable environments for extraterrestrial life. Enceladus moves at an orbit 238,000 kilometers from Saturn's center. The evidence so far points to the fact that Enceladus must have been recently active with water volcanism. This is the most suitable explanation for its young surface. The Cassini space mission has helped us learn about the existence of cryovolcanoes near the South Pole, shooting geyser-like jets of water vapor. So far, more than 100 geysers have been identified, and some of the water vapor falls back as snow while the rest escapes. supplying most of the material making up Saturn's E-ring. The possibility that Enceladus is an ocean world thrilled scientists so much that they began developing more space mission programs to study the Enceladus better. Although these programs will cost billions of dollars, the thrill of discovering that the ocean world of Enceladus can support life, or currently supports life, is a great motivation to keep working. Currently, there are many space missions in the works by NASA and other space agencies, hoping to uncover more facts about the Enceladus. However, it seems that the James Webb Space Telescope, JWST, has beaten everyone in confirming what may be considered the discovery of the decade. If there is one thing we can bank on with the Webb telescope, it is that it will uncover mysteries about our solar system that other telescopes and spacecraft cannot. From discovering the most distant active supermassive black hole to detecting organic molecules 12 billion light-years away in a galaxy, the Webb telescope is unarguably the most effective telescope currently out in space. It is also the largest telescope in space and has achieved remarkable feats thanks to its high resolution and high sensitivity instruments. Designed to conduct space exploration using infrared astronomy, the James Webb Telescope has executed its function perfectly with its latest discovery about Enceladus. The high-resolution instruments of the Webb telescope were recently put to use, and they spotted a water vapor plume in Enceladus. Ordinarily, this isn't surprising, as Cassini has provided the scientific community with similar information. However, what the Webb telescope uncovered is different. The telescope discovered a water vapor plume that spans more than 6,000 miles, which is nearly the distance from Los Angeles, California, to Buenos Aires, Argentina. Incredible, isn't it? This massive water emission hasn't been seen by scientists before. It's a record-breaking water plume eruption, whose existence we wouldn't have known if not for the James Webb Telescope. The Webb Telescope first captured images of the erupting water plume on the 9th of November, 2022. In the months following this event, NASA scientists studied more data to evaluate this discovery. This explains why NASA was initially mute about the discovery and has waited until now before breaking its silence. We can't blame them for taking their time because the discovery shakes the foundation of everything we learned about Enceladus. Although the Cassini spacecraft had spotted plumes jetting for hundreds of miles between cracks, also known as tiger stripes, that discovery is small compared to the over 6,000 miles wide water plumes seen in Enceladus. The Webb telescope's discovery is terrific, as it proves that there is a global saltwater ocean beneath the icy crust of the Enceladus. Also, what makes the story more exciting is that scientists are having a direct look at the water plume back on Earth. For the first time, we could see how this emission feeds the water supply for the entire system of Saturn and its rings. This has confirmed the centuries-long belief that Enceladus holds a special place in Saturn. According to scientist Geronimo Villanueva, who works at NASA's Goddard Space Flight Center in Greenbelt, Maryland, he was shocked that the Webb telescope had detected a water plume more than 20 times the size of Enceladus. He initially thought the data might be wrong, but the James Webb telescope was known for its efficiency. From the observed data, astronomers have seen that the water plume extends far beyond its release region at the South Pole. If you are intrigued by the span of the water plume, wait till you hear about another physical characteristic. The water vapor gushes from the plume at 79 gallons per second. You would agree that this is impressive, because it means the water flows fast enough to fill an Olympic-sized swimming pool in just a few hours. For context, it would take about 2 weeks to fill the same swimming pool with a garden hose. If you are wondering why the Cassini spacecraft could not detect this water plume, despite spending over a decade exploring Saturn and its moons, the answer lies in the fact that the Webb telescope is operating from the Sun-Earth Lagrange Point 2. This distinct view is over 1 million miles from the Earth and provides a good position for the telescope to use its highly sensitive near-infrared spectrograph instrument to study the surface of Enceladus. The James Webb Telescope confirmed that Enceladus's orbit around Saturn takes about 33 hours, which is fast. However, the information we didn't have earlier was that as Enceladus rotates around Saturn, The moon and its jets are spitting off water, leaving behind a halo in their wake, almost like a donut. According to the scientist Geronimo Villanueva, the Webb observations not only showed that the water plume was huge, but also that there was water everywhere. That's a whole lot of water. As expected, astronomers didn't waste any time investigating these observations. They described this fuzzy donut of water which appeared everywhere as a torus. They discovered that the torus is co-located with Saturn's outermost and widest ring, the E ring. The observed data show us how the water vapor plume feeds the torus, and scientists have determined that about 30% of the water stays within the torus, while the remaining 70% escapes, supplying the other part of the Saturnian water system. You would agree that this is quite an organized system. The Webb telescope has provided us with a specific way to directly measure how water evolves and changes over time across Enceladus's plume. The telescope's observations were completed under Guaranteed Time Observations, GTO program 1250. The initial objective of this program was to demonstrate the capabilities of the telescope in a particular area of science and set the stage for further studies. Now, the scientists who designed this program have had their dream fulfilled unexpectedly. According to Heidi Hamel of the Association of Universities for Research in Astronomy, the GTO program is proof of concept after many years of developing the observatory. You can understand Hamel's delight in the telescope's groundbreaking discovery because he is a Webb interdisciplinary scientist and the leader of the GTO program. A NASA Goddard Space Flight Center scientist, Stephanie Malam, says that the Webb telescope will help us uncover more information about Enceladus as we learn more about the composition of its ocean. There is so much optimism about the forthcoming discoveries about Enceladus due to the impressive wavelength coverage and sensitivity of the Webb telescope. NASA has documented the discovery of the water plume in a study accepted for publication in the Nature Astronomy journal. Scientists are planning a prolonged study of Enceladus, where they will dedicate 6 times more duration than the original study. They plan to uncover chemical compounds associated with habitability, such as organic compounds and hydrogen peroxides. This is the main reason why astronomers began studying Enceladus in the first place. Enceladus is one of the most reflective celestial bodies in our solar system, and this is due to the fresh, clean ice that covers its salty water. Its surface temperature at noon only reaches -198 degrees Celsius, which is far colder than a light-absorbing body would be. Yet this doesn't eliminate the possibility of finding life deep inside the moon's ocean. Who knows, some living organisms could have existed for millions of years within the icy layers of salty water. These organisms could cure some deadly infections and diseases, such as cancer. We could even see some living organisms believed to be extinct or myths flourishing deep in the ocean water of Enceladus. We can't rule anything out. This possibility of life has led to many proposals for further exploration of Enceladus's ocean, currently in evaluation or development stages. For instance, in November 2017, Russian billionaire Yuri Milner showed interest in funding a low-cost, privately funded mission to Enceladus. By September 2018, NASA and Breakthrough Initiatives signed a cooperation agreement for the mission's initial concept phase. The design concept is that the spacecraft will be low-cost, low-mass, and launched at high speed on an affordable rocket. The spacecraft's mission would see it perform a single flyby through the plumes of the Enceladus to sample and analyze its content for biosignatures. NASA provided the scientific and technical expertise to begin operations of the spacecraft's construction. Similarly, in 2022, the Planetary Science Decadal Survey by the National Academy of Sciences recommended that NASA prioritize its latest probe concept, called the Enceladus Orbilander. This one-of-a-kind spacecraft will be launched on an affordable rocket, but would cost NASA about $5 billion. Also, it will be designed to spend 18 months in orbit as it inspects the moon's plumes before landing on Enceladus, where it would spend 2 Earth years conducting surface astrobiology research. Before Enceladus Orbilander came into the picture, German scientists had been developing the Enceladus Explorer, NX. The Explorer is a planned interplanetary orbiter and lander mission. It is equipped with an ice-melting probe that can be easily steered in motion and can assess the existence of life in Enceladus. The space mission is an astrobiology project funded by the German Aerospace Center, DLR, and a consortium of 7 German universities carries out its research. German scientists commenced the collaborative project on the 22nd of February, 2012. While we await the completion and launch of these space missions, the scientific community is still focused on the James Webb Telescope. The telescope is the reason we discovered the mind-blowing 6,000-mile-long water plume eruption in the first place, and it will continue to provide us with a high-resolution view of Enceladus's ocean. Scientists are very optimistic that we will still uncover more surprising facts about Enceladus through the Webb telescope. The window of opportunity is quite wide, and we can't predict what we will see next in the coming days. Who knows? We might find out the source of heat of the planetary body. Although there have been several hypotheses on the heat source, scientists are still searching for more proof, and the JWST might just help us with that. Do you agree with this? We will find out soon enough. Thank you for watching another episode of Voyager. While you are here, click the video on your screen to see more mind-blowing space videos like this one.